Hello, welcome to Excellent Link Academy. For today, we're discussing about a very important concept in physics known as vector. Let's define vector and look at the magnitude and modulus of a vector and also how to represent a vector, right? So let's look at the first things first. Vector, by definition, a vector is simply a quantity that has both magnitude and direction, right? So vector are simply quantities that has both magnitude and direction. Examples of vector quantities include displacement, velocity, force, weight, and etc. There are several examples on vector, so you can try to search online. You see several other examples on vector. All right, I haven't discussed the definition of vector as a physical quantity that has both magnitude and direction. By magnitude, we mean numeric value and then direction. All right, let's dive into something very, very important known as representation of a vector. Representation, representation of a vector. How do you represent vector? Let's discuss representation of a vector. To represent a vector, there are about four distinct ways of representing a vector. There are four ways of representing a vector. Number one is called the use of arrow. As in this case, let's say I have a vector A. So the use of arrow. So this is a means of representing a vector. Let's say we are using vector A, for instance. So this is a way of representing a vector. All right, this is first representation of vector, the use of arrow, as you can see. Number two way of representing a vector is um, in the form something of this nature. This is second way of representing a vector in the form this. So when I see something like this, it means what? Vector A, right? I'm using A. I can use B, I can use C, but I'm using A here. This means vector A, or perhaps also vector A. So you can represent vector using arrow, as in this case, in the form this. The third way of representing a vector is the use of bold letter, use of bold face, use of bold face, right? Bold face letter, use of boldface, right? I mean boldface letter, as in this case, let's say I have the use of bold face letter, as you can see. So we represent vector in this form. This concept here is actually used mostly in scientific textbooks. You'll be seeing how the writing structure of this nature is a way of representing a vector, the use of bold face, as in this case. So it's a means of representing a vector. All right, let's discuss the fourth representation of vector, known as the use of caret. The use of caret, as in this case. So this means a caret, something of this nature, right? This means a vector A current, right? So these are like the four distinct way of representing a vector. Number one there, the use of arrow. Number two, in the form. Number three, use of bold letter face, as in this, as you can see. And number four, use of caret. Having discussed the representation of vector, let's look at something important, or perhaps let's dive into something very important known as the modulus or magnitude of a vector. Let's discuss something important known as the modulus of or magnitude of a vector. Either you call it modulus or you call it magnitude, right, of a vector. All right, when it comes to the modulus of magnitude of a vector, I will give you the mathematical expression for it, right? So let's say I have a vector A. I have a vector A, as in this case, to be equal to AXI plus AYK plus AZJ. As in this case, let's say I have a vector A to be equal to AXI plus AYK plus AZJ. The modulus of the vector is written as vector A, as in this case. So if you are seeing this symbol, it means that you are looking for what? The modulus of vector A. So this two stroke here represent modulus or perhaps magnitude of vector A. So mathematically is equal to the square root of the coefficient of I squared. So the coefficient of I here is what? AX. I will square it plus the coefficient of K, which is what? AY all squared plus the coefficient of J is what? AZ all squared. So this is how to find the modulus or the magnitude of a vector. Simply take the coefficient of I, J, K and square them and sum them all together. So as you can see, the coefficient of I here is AX. As you can see, AX, I'll square it plus the coefficient of K here is AY. As you can see, square it plus J is what? AZ and square it. This is how to find the modulus or perhaps the magnitude of a vector. Let's use this idea to solve several examples and let's see how it works. Example 1. Example 1. Let's say I have a vector A to be equal to 3I plus 2J plus 4K, as in this case. And I'm told to find, the question say, find this. This means what? The modulus of what? Or perhaps the magnitude of what? Of vector A. So we said to find the magnitude solution of vector A. What's the concept? The magnitude of vector A is equal to what? The square root of, pick out the coefficient of I, J, K and square them and sum them all together. The coefficient of I is 3 here, 3 all squared plus the coefficient of J is 2 plus 2, that becomes 2 squared plus coefficient of K is what? 4, that becomes 4 squared. Let's get the modulus or perhaps the magnitude of this vector A. The modulus or magnitude of vector A is equal to the square root of 3 square gives 9 plus 2 square gives 4 plus 4 square gives 16. If I sum this value together, the modulus or perhaps the magnitude of vector A will be equal to 16 plus 4 will give 20 plus 9 will give 29. That becomes root 29. So it means that the modulus or perhaps the magnitude of this vector is equal to root 29. Or you can put your answer in decimal form, right? In 2 decimal place. If I punch this on my calculator, if I punch root 29, I'll have 3.28. Sorry, I have 5.38 if you wish, but not that important. If you wish, you can put your answer in decimal form as two decimal places, as you can see. So it means that the modulus and the, or perhaps the magnitude of vector A is this, as you can see. Let's take other example to further explain modulus of a vector. The one I give you here is having plus plus. What of it is having negative sign? How do you do that? So example 2. Example 2. Let's say I have a vector m, a vector m to be equal to 3i minus 2j minus 4k. I'm going to find the magnitude of vector m. I'm going to find the magnitude of vector m. How do you go about this? All right, first things first, your first task here is to take the mathematical expression of modulus or perhaps magnitude. We said for magnitude A, solution, magnitude of vector m will be equal to the square root of the coefficient of I. Here is 3, so I'll have 3 squared plus the coefficient of j is what? Minus 2, please. So I'll have minus 2 all squared. Observe, encase them in a bracket when it comes to minus. So minus 2 all squared. This is plus into the coefficient of k is minus 4. I have minus 4 all squared. Let's get value. From here, it means that the modulus of vector m will be equal to the square root of 3 squared gives 9 plus minus 2 squared will give 4. If I have minus 2 squared, this means minus 2 times minus 2. Minus minus is plus, 2 times 2 is 4. So that I'm having plus 4 here. So that's the concept. All right, plus minus 4 squared we give 16. Right, we give 16. At this point here, let's find the modulus or perhaps the magnitude of vector m will be equal to the square root of observe that I'm having the same thing here, right? So I will have 29 here. So it means that the modulus or perhaps the magnitude of vector m will be equal to root 29, as you can see. Now observe something, please. If you are told to find, I purposely use the same example, as you can see, the same question, but I just use negative here. Irrespective of the sign, listen, plus plus, I'm having positive positive here, I'm having negative negative here. Irrespective of the sign, the condition is that it so far is okay, let me use this concept. I'm using plus here, I have root 29 here. Let's say I'm given the same question as you can see the same question, but negative. I'll still have what? My square root of root 9. Why? Because I'm looking for modulus, or perhaps I'm looking for magnitude. They are both the same, modulus or magnitude of a vector. It means that when it comes to taking the square root of each coefficient, irrespective of the sign, they'll end up what? Adding up. They'll end up adding up, as you can see, 9 plus 4 plus 16, irrespective of what? Of their sign. Right, that's the concept behind modulus or magnitude of a vector. Let's discuss something very important known as unit vector. All right, let's discuss unit vector. Let's discuss unit vector. When it comes to physics, or perhaps scientific approach, when you hear the word unit or perhaps unity, it means one. When something is one, it's said to be what? Unit or unity. So by definition, a unit vector is simply a vector whose magnitude or modulus is equal to 1. So when the magnitude or perhaps the modulus of a vector is equal to 1 is known as what? A unit vector. A unit vector is represented using a caret, right? A caret. So let's say okay, let me explain this concept here. Look up please, let me explain something. If I have vector A, this is called what? Position vector. This is called position vector of A. This is called position vector of A. If I have this one here, what we know, we just discussed this earlier. This is called what there? This is called the what? Magnitude of vector A. As you can see, vector A. And let's say I have this one here. This is called what the unit vector. So we use a current to represent what the unit vector, as you can see. So this one here is called position vector. This is called the magnitude or modulus of vector A, and this is called unit vector of A of vector A. All right, when it comes to unit vector, what is the mathematical representation or the mathematical expression for unit vector? Note that mathematically, unit vector is equal to position vector all over magnitude of the vector So it's important to note that unit vector is equal to position vector all over magnitude of the vector. So it means that let's say I'm using vector A for instance. It means that unit vector A current is equal to what? Position vector, that's this, right? All over magnitude of the vector. This is magnitude, yeah, of the vector. This is a mathematical expression for unit vector. So it means that to find a unit vector, there are two things needed. Number one, there is what? Position vector. Number two, there is what? Magnitude or modulus of that vector. All right, let's use this idea to solve some example, and let's see how to find problem under unit vector. All right, example 1. Let's say I'm given a vector A to be equal to 3i plus 10j plus 2k, and I'm told to find A current. This is called what? The unit vector of A. So I'm told to find unit vector of A. We said when it comes to finding solution, the unit vector of A current is equal to, which is unit vector, is equal to what? Position vector of A all over the magnitude or the modulus of vector A. So let's find the unit vector of A. It means that to find the unit vector of A, I need two things. Number one is what? The position vector of A. Number two is what? The modulus or the magnitude of vector A. So it means that from here now, I know one thing. what is the thing I know? I know position vector. This is my position vector here. So the next task was look for what? Magnitude of vector A, or perhaps modulus. So it means that now from here, the magnitude of vector A is equal to the square root of the quotient of I here is 3. That becomes 3 squared plus this is 10 squared plus this is what? 2 squared. From here, the magnitude of vector A will be equal to the square root of 3 squared will give 9 plus 10 squared will give 100 plus 4. I'm here. Alright, from here now, I'll be having, if I sum them up together, if I sum them up here, it means that the modulus of vector A is equal to the square root of 113. Right? 9 plus 4 will give 13. 10 plus 100 will give 113. So it means that the modulus of vector A is this, right? So it means that it's not quite simple for me to look for now. So to find the unit vector of A, that is unit vector, therefore the unit vector of A is equal to what? We said first is first, position vector all over what? The modulus of vector A. So my the unit vector of A is equal to position vector A is everything here. That's what? 3i plus 10j plus 2k all over magnitude or modulus of vector A is what there is root 113. As you can see from here now, I can now at this point here I can't leave my answer this way. It's not well expressed. So my next task is to simplify this. So I'll have that the unit vector of A is equal to, pick out this one, this is 3 all over root 113. Then this I, I'll put I here, plus this is 10 all over root 113. Then I'll put J here. Next up, plus this is 2 all over root 113. Then I'll put what there? I'll put K here. This is the unit vector of this question here. When it comes to unit vector, we said unit vector is simply a vector whose magnitude or modulus is equal to 1. It means that if I take the modulus of this answer here, it must give me 1. So to prove that this is a unit vector, let me show you the proof. Listen, if I take the square root of each vector, if I take the square root of this unit vector, it must give me 1. And we said for unit vector, the condition there is what? It must be 1. Let's now confirm if it's 1. So if I take the modulus of unit vector, the modulus of unit vector A is equal to the square root of, this is I, this coefficient, that becomes 3 over root 113 all squared plus 10 over root 113 all squared plus 2 over root 113 all squared. So I take the modulus of my unit vector, it must give me 1. So let's check if it's 1. Alright, from here now, apply the concept of indices. From here, this square will affect each of these. So I'll be having the magnitude of unit vector A is equal to the square root of, I'll be having 3 squared all over, observe, okay, all over root 113 all squared plus 10 squared over root 113 all squared plus 2 squared over root 113 all squared. Alright, for me now, the magnitude of the unit vector A is equal to 3 squared give 9 over square capital square root 113 plus 10 squared 100 over this cancel out this 113 plus this cancel out this, that's 2, that's 4 over 113. If I'm having the, when it comes to fraction, if I'm having the same denominator, I'll pick 1. So I'll have that the magnitude of unit vector A is square root of what? Pick out 113. They are the same, pick out 1. Add their numerator, 9 plus 100 plus 4. So from here now, if I simplify this more better, I'll have that the magnitude of this unit vector is equal to root what? 9 plus 4 plus 9. That will give about, what do we get it for? About 113. That's what you'll be giving. Observe, I'll be having 113 over 113. 113 over 113, that will give what? The root 1. This is where this is 1. Root 1 will give 1. Observe that the magnitude of this unit vector is equal to 1. So that I say that when you take the magnitude or modulus of a vector, of a unit vector, it must give you 1. So I have 1 here. This is how to solve problem under unit vector. See you in our next class. Next class we discuss about the addition and subtraction of a vector.